project about our group 10. So here is my group member Piyush, Tanya, and Anita, and myself Mangalam Bhatt. So the project was about extracting polyphenol from the dried tea. So here it was all about the project. The project objective was to achieve the high yield of the polyphenol in the tea leaves. So we used so many innovative process to extract the high yield amount of the polyphenol in the tea leaves. So our main goal is to achieve the highest yield in the tea using the different solvents and the temperature. So traditional method is good for extracting polyphenol in the tea leaves, and I think everyone who is using tea on the daily basis are consuming the polyphenol by drinking tea on the daily basis. It is just a traditional method of extracting polyphenol, but here we use some innovative techniques like using the rotavator. We extracted the most of the yield from the tea of the polyphenol. So here you can see investigating the different technique of the extraction, like extracting by the rotavator and as well as the vacuum filtration and liquid extraction using the scorbic acid. So tea is the polyphenol is the most essential for our bodies, but because it is useful for preventing some chronic disease, and as well as it may be helpful to prevent some diabetes and as well as the cancer, because it has the polyphenolic compound in the tea. We thought that extracting polyphenol and knowing about the yield in the different tea, we used about two or three tea to get the maximum polyphenol yield from that three type of tea using the different temperature. Like we used around 4 different temperature for the 3 of them, and we used different solvent as well. Like we used methanol and the water for the extracting polyphenol, and in the further slide we are going to explain you about how much polyphenol yield we got from the different tea using the different temperature and different solvents. So here is the outline of the work plan, which will be explained by Anita.
So moving on to the outline of our work plan, we started our on week 3 we started our procedure by the polyphenol extraction from tea powder. We used the Tetley tea powder. On week 5 we had done the decaffeination, since the tea may contain caffeine, and the polyphenol extract from the decaffeinated crude extract. From week 6 to week 10 we didn't find the foreign reagent that can be used for our polyphenol determination. So we further do the polyphenol extract from different brands of tea powder, that includes fresh tea powder, Indian tea, and Elizabeth tea. In week 11 we prepared gallic acid stock solution, because we use gallic acid as our standard solution for the determination of polyphenol content. On week 12 we had done the determination of polyphenol content by Folin cytocalcium assay. The extraction of polyphenol from the tea powder. We weighed about 6 grams of tea powder and transferred into a beaker. We had used two solvents, that is water and methanol. For water, we heated the solution at different temperature, ranging from 50 degrees Celsius to 80 degrees Celsius. That is, we use 50, 60, 70 and 80 degrees Celsius. For methanol, since its boiling point is 64.7 degrees Celsius, we heated the solution at 30 degree, 40 degree, 45 and 50 degrees Celsius. We heated the whole solution for about 15 minutes, and after that we filtered the solution through vacuum filtration, and we had done the rotary evaporation to get a concentrated solution of polyphenol extract. The next step was decaffeination process. We done this through liquid extraction. Decaffeination is done since tea contains caffeine in it. The extract solution we obtained after rotary evaporation, we transferred it into a secondary funnel. We also add equal volume of dichloromethane. For example, if we get 5 ml of extract solution, we add 5 ml of dichloromethane into the separated funnel. The two layers were formed, and the lower layer contains the caffeine and the upper layer contains undissolved polyphenol extract. We collected the upper layer and examined it for the used it for the further process. The polyphenol extraction from decaffeinated extract will be explained by Piyush.
Yeah, so after getting that undissolved tea concentration, we further processed with the 50 ml of ethyl acetate, and we use ascorbic acid to prevent the oxidation process. We just collect and then we just put it in the separating funnel, both the things, and then shake it and leave it for like 15 minutes. And then we collect the upper portion that contains polyphenol in it, it will dissolve in ethyl acetate. Then we use that rotawave to make it more concentrated, to evaporate more ethyl acetate from the polyphenol. Furthermore, for determining the polyphenol content, we make the stock solution of gallic acid. We used 0.5 grams of gallic acid and added 10 ml of ethanol in it, and the further was water inside it, and then we make a standard graph. And then from our solutions, we add 5 ml of distilled water for the water samples. We have like 16 samples. So we add 5 ml of distilled water for the water samples and 5 ml for methanol, 5 ml methanol for the methanol samples. Then we transfer 20 microliters in the cuvette to make that to use in that graph. We add 1.58 ml of water inside it, and then added only 100 microliter of foreign recalculator, and then leave it for like 8 minutes to have the process. And then we add the sodium carbonate solution. We separately make that sodium carbonate solutions. We use 20 grams of sodium carbonate powder and 80 ml of water, and then we boil it for 10 to 15 minutes, and then we add few grams of powder of sodium carbonate and leave it for 24 hours to have the sodium carbonate, to make some sodium carbonate solution. And then we added 300 microliters inside the cuvette, and we then leave it for like 20 degree for 1 hour. That all the samples, we make 16 samples, and then we observed in that UV spectrometer at 65 nanometers wavelength. Then we got this concentration. You can see that for Tetley tea, water 60 degree would be like we get the 495 milligram per liter concentration, which was the good, and then other was at 80 degree, which is like 533. So those are the key the temperature for water we are looking for. And then for methanol, it would be like the 45 degrees. So at that degree we get like maximum amount of concentration of polyphenol content. And then those are FTP is like the fresh tea. That first Tetley tea was expired, so Margaret gave us a new fresh tea of that Tetley. So for that as well, we get the maximum yield at 60 degree. For methanol, it was showing that it was out of range. I don't know why, but it will be like the higher than we had that in the stock solution. For Indian tea, we make water at 60 and methanol for 45 for the yield. And the last one is English tea, which at methanol we will get the higher concentration of polyphenols. Further process would be discussed by Tanya.
Hello everyone. So this is the ANOVA comparison which we made in the Minitab for our statical data. So as Piyush earlier said that we have a different samples and we got a different absorbance and a concentration, and it is quite similar to each other, that we already showed it here, that but there is a quite little change was observed in the Tetley tea at 80 degrees Celsius, and English tea with a different solvent as a methanol at 45 degrees Celsius, which is a quite more than 500 degrees Celsius of a 500 degree concentration. So let's start with the challenges that we are facing. Lots of challenges. First and the foremost, late arrival of our reagent. Because of that, our all process was delaying day by day. Apart from this, there was a interferences of a different tea powders, that we are using a 4 teas with a different temperatures and a different solvents, and we are confused and excited about the different results, that what will we get. Like we already used expired one, fresh one, and it also suspects its oxidation level. Like we already keep our samples for a long hours and a long days. It's like challenging for us that what will we get. Is it possible to get a reliable results that we are already expecting that? So this is a very big challenge for us to get a reliable results. Apart from that, maintaining constant temperature is also a big challenge. Like because of their melting point and a different temperature, it is difficult to heat the sample again and again. So we made duplicate, triplicates of the all samples, but it is so challenging to maintain the constant temperature with a constant time, like in the 50 minutes. Like we usually do these kinds of things to maintain the temperature while doing hot and cold method. So to sum up that all these things, finally we are using a different tea samples with a different temperatures and maintaining all solvents. So after this, we are getting the equal amount of concentration and absorbance by using a UV spectrometer, and we get our results, which is totally expecting and reliable to our results, and we are very happy to get that. So these are the process that we made in this week, and we learned lots of things in that. So thank you to all to come here and listen to us.
What would be the future implications of your research work?
Further step? Are you asking the further step?
Yeah, asking about future implications, like what else you can do with this project.
The polyphenol, as we explained in the first slide, that it have an antioxidant property. We also decided to do the antioxidant determine the evaluation of antioxidant activity in the polyphenol, but we don't have the reagent for that. So you can also use done the antioxidant evaluation and make a correlation between the polyphenol content and antioxidant property of the polyphenol.
Can you go to the slide where you created like water and methanol different temperatures? Further ahead. Further.
Yeah.
Up. Yeah.
Yeah.
Yeah. And after that slide, you use you need this is okay decaffeination. So for the water part, you use dichloromethane to do the. But what you did?
Yeah, same as methanol. For methanol, we use
Dichloromethane. But are they miscible or not? Because I think like dichloromethane is miscible with the methanol, and there will be no liquid extraction.
No, we got the separate layers of both the solutions.
We do have the picture, but we didn't include it in the slide.
We have been that.
The table that's 3 slides down, could you pull that up? Yeah. Perhaps it's just not visible, but maybe it's in that black banner. What is the first and second column representing?
Definitely water at 50 degrees Celsius. Its concentration is 480.122, and the definitely water at 60 degrees Celsius, and its concentration is 495.
So what is the middle column there?
It's
the
absorbed now.
Absorption.
Yeah.
Oh,
What is
okay.
concentration? The last one is
That's the
concentration.
Concentration of
What is the unit of that concentration?
milligram per liter.
Yep. First,
Yeah.
That's a different temperature with a methanol and a different solvent because of that is
In water, the boiling point starts at 70 degrees. So when we heat it at 70 degrees, just the boiling starts only. We see a loss in that one. But when it reaches 80 degrees, it may become stable. So we get a better concentration when compared with the 70 degrees.
You mentioned a few industries that use this compound. What conclusions could companies working in those industries draw from the data that you're collecting?
It can be used in medical industry that it have antioxidant property. The polyphenol have antioxidant property, anti-inflammatory and anti-carcinogenic, I guess so. And in also food industry, I guess it have applications in the food industry also. Polyphenol.
Yes, that's what they use the compound for, but why would they be interested in the project that you did?
Because tea powder is easily accessible for everyone. To get the polyphenol, our process is extraction of polyphenol, and we can easily get tea powder also. So it is easily accessible to get tea powder and extract the polyphenol for the process.
And hypothetically, would a company in one of those industries be happy with the data that you collected?
Hope so.
okay, I have question. So, first thing, okay. So all of your samples you use black tea, right?
Yeah.
Black. So if you have, is there any green tea there?
No.
So my question is general, like if you have green tea versus black tea, which one will have more polyphenol?
I think the green one.
Green one.
Green one, okay. Okay. And you have done some decaffeination.
Yeah.
Okay. So is there any instrument that can you use to determine the concentration of caffeine, suppose remain there or remove completely? Can you use spectrophotometer or you need to use any other instrument? Very other.
We didn't work
Actually,
on that.
they did use the spectrophotometer. You will use the spectrophotometer at 760.
Yeah, for polyphenol. Polyphenol. I'm
Yeah.
talking about caffeine.
For the
Caffeine determination. Okay, no problem. And last one, so your chemical compound is polyphenol, and you have used gallic acid as standard, right? So do you have any idea like how close those chemical structures are? Polyphenol in your tea or gallic acid chemical structure? Those are very close, or is there something different?
The gallic acid contains the phenol compound, so it's somewhat similar to the polyphenol. That's why